Okay. So in this case, you can see parallel.for is there, right? So if you go to the parallel, so it's a static class. You can say go to the definition of parallel. It's a static class. Static class means what? Now every method or every member defined in this class is going to be static. So you can see there are many overloaded version of for each loop and a invoke. So basically this class provides three different methods. One is for, another one is for each, and another one is invoke. These three methods we are trying to cover today. So this is the sequential for loop. And now if I'm going to use a parallel for loop, then what? I will start this loop from 0. I will start this as 10, right? And I'm writing this I, then I'm using these things, right? And you can call this method, right? That is fine. So this is the parallel for loop. So now in this case, multiple threads is going to execute to this method parallel. It might be possible that 2 thread, 3 thread, 5 thread, 10 thread, right? Based on your available processor, right? This method is going to be executed, right? But even you can also control the number of threads that are going to execute this method, right? That is what we can see, right? So what is saying now, parallel programming allow us to divide a task into different parts and work on those parts parallelly. See, in this case, if you are implementing parallel programming, right? So what is this parallel for? I will discuss in details, right? This is what parallel for loop is, right? So in this case, the task is divided. So this is the sequential for loop or standard for loop. This is parallel for loop. In this case, only one thread is going to execute the application code one by one. In this case, so the multiple thread is going to execute the application code one by one, right? That means the task is divided. That task is divided to be executed by multiple threads. An example might be that we have set up a credit card and we want to process them parallelly. See, in our previous application, we have seen the credit card example, right? And in that example, we have seen how if instead of processing the credit card one by one or asynchronously, right, we can also process the credit card parallelly. That is what we are going to see. In general, we use CPU bound operations, right? We generally we use parallelism in CPU bound operations, right? What is CPU bound operations? Now, CPU bound operations are those operations whose resolution depends on processor, right? CPU bound operation means what? The operations which, right, how easily, right? So basically the processing time is completely depend on the processor. If the processing time is completely depend upon the processor, then these operations are nothing but your CPU bound operation. But while we are talking about these things, right? If you are communicating with the external system, in this case, does it going to depend on your processing time, right? No, it is not going to depend on the processing time. Is not depend on your processor. Why? Because in this case, I'm communicating with the external system. External system means that system having its own processor, right? How much time that processor? So from your machine, right? For example, suppose your machine, right? Your machine having the API, right? And this is my machine, right? Right, from my machine, I'm communicating with your machine, right? Communicating with your machine, right? So I'm consuming your API means I'm communicating with your machine. So while I'm communicating with your machine, can I manage your processor time? Can I manage the CPU of your processor, CPU of your machine? Is this possible?
No.
No. That means what? Then if it is not possible to manage the CPU, then it's not a CPU bound operation, right? So it's not possible, it's impossible that from my application, from my machine, I can manage your CPU, right? It's not possible. So if not possible, then that is not a CPU bound operation. But in this case, can I manage this thing? Right? Instead of executing this loop one by one using a single thread, I can use multiple thread to execute my application code. So in that case, the CPU is going to be utilized properly. Instead of using single thread, I can use multiple thread, and where the CPU utilization is going to be high. So this is nothing but a CPU bound operations, right? So that is what you have to remember. See, the CPU-bound operations are those operations whose resolution depend on processor, not on services external to the application. It should not be an external application. Doing an arithmetic operation will be an example of CPU-bound operation. Executing a loop is another CPU-bound operation. That means whenever you are executing some logic in your application, right? That is nothing but a CPU-bound operation. But whenever you are calling some external, you are communicating with some external system, that is not a CPU bound operation, that is a IO operation, right? So it is important to note that parallelism is not always beneficial in terms of a performance, right? So don't think that this concept parallel programming is available and I can blindly use this thing, right? Don't think that. See, using parallelism has a cost, right? Suppose you want to use parallelism, right? So in this case, if you look at this thing, right? So in this case, I'm using parallelism. So if for using parallelism, there is a cost. What is the cost? Suppose in this case, 5 threads are going to be created. 5 threads are going to be execute the application code. After executing the application code, the thread are going to be deleted. The thread creation, right? So managing the thread will going to take some time or not. Nothing is free in this world, right? If you are using parallelism behind the scene, right? Something is going to be happen. That thing, what is happening behind the scene, is also going to take some time, right? Everything having a cost, right? So don't think that. So in this case, if I comment this loop, right? Now, if you use this for loop and if you use this for loop, then this for loop is going to give you better result than this one, right? And if I'm removing this, then now this parallel for loop is going to give you better result, right? So don't think that this parallel for loop is available, I can blindly use and it will give me better performance, right? Everything has having a cost, right? So this is the point that you need to use, right? The benefit of
So
a parallel. So yeah.
yeah, so can you go in the program? So in this program, like as you said, like on line number 28, if you are using thread.sleep and if you are using that parallel for loop, then that one thread will start and it will sleep for like 5 seconds, then another thread will start. So like both thread are in sleep. So at that time also we are consuming that CPU, right?
Exactly.
Okay.
Right. So, but in this case, if I comment this statement, right, then this sequential for loop will give you better performance.
Yes.
But if I'm using a parallel for loop, it is going to take more time than this sequential for loop. I will show you this thing practical, right?
Okay. Yeah.
So everything I'm going to show you practical. This is the theoretical time, right? The benefit of parallelism depends on the amount of work to be parallelized, right? See, in this case, if you are using parallel programming, right, then you have to understand for each iteration, right? For each iteration, the task I'm going to perform, it is a time consuming task or it's a simple task. That is the point that you need to remember. So in this case, you can say it is not a time consuming task, right? Within milliseconds, this is going to be completed. If it is not a time consuming task in this sense, right, for each item, right, that item, so in this case number 0 to 9, right, that is what going to store in this variable, right? And using that variable I'm going to perform some task and that task is going to be completed immediately. It's not a time consuming task, right? So if it is not a time consuming task, then don't use parallel programming. In that case, sequential programming is going to give you better performance, right? But the thing is that if it's a time consuming task, then it is going to be better to use parallel programming. For example, you can say uh, you can see on Facebook approximately 250,000 photos are uploaded per minute. 250,000 photos are uploaded per minute. And as you can imagine, it can take a lot of power to process such a high volume of information. And it is processing. And how it is processing? Because of the parallel programming, right? Parallelism shows benefits, right? Finally, parallelism shows benefits. If the computer where the program is running, if the computer where the program is running has parallelism capability. For example, if you are using parallelism, the parallelism is going to show you benefit, right? Only when where you are running the application, right? The computer or the machine where you are running the parallel programming. If that machine having the capability to handle the parallelism, capability in the sense it should have a multi-core. right? In this case, you can see I'm having 8 logical processor, 4 core, each core having each core can process 2 tasks. Why? Because the total number of logical processor is 8. If you are having a single core, then if you are using if your machine having a single core, and if you are using parallel programming, right? Then in that case, don't think that it is going to give you better performance. In that case, you will not get any error, right? But your application execution is going to be sequential, because only one core is there. That core is going to execute a single task, right? If multi-core, multiple task is going to be executed parallelly. If one core, only one task is going to be executed. So depending upon the processor, right, the parallelism is going to be handled, right? But think that if you are having a single processor, then it is not going to give you any error, but it will not be faster. Why? Because in that case, the application execution is going to be sequentially. Is that clear? Right? But nowadays the modern processor, right, modern computer, whatever we are used, they are multi-core, right? So in multi-core, say you can see this is task manager, and you can check your multi-core processor how many core, right? 4 cores on my machine, 8 logical processor, right? So number of a processor is 8. So 8 different thread can execute my application code, right? At this time, this parallel for each loop is going to execute by 8 I mean for 10 times, then at a single time 8 thread will come and execute my application, right? That is what I'm going to show you practically, right? And there are in two ways we can work with parallelism. One is task parallel library, and another is parallel link, right? What is parallel link queue? I'm not going to talk right now, right? Mostly once we cover, I will give you a simple introduction to parallel link queue, right? A later part of I mean in the next video. But once we cover the link queue concept, then you will understand this p-link queue in a better manner. So what our agenda for today is task parallel library, right? So basically, if you go to the parallel class, right, then you will see that parallel class providing us some method, right? And we are going to use those method to implement parallel programming, right? Once we use those method, like you can say this is a for method, right? So this is a method. So even though we are saying it is a loop, but technically if you see it's a method, right? So this for method, right, handling the high level, it is going to handle the in detail things behind the scene, right? How the thread is going to be created, how the thread is going to be managed, how the thread is going to execute the task, right? Everything is hidden to us, and everything is going to be managed by this for loop, right? So this is the thing you can see. The task parallel library, right, is a library that makes life easier for us. When we see parallelism in our program, that TPL, right, that task parallel library abstract the low level details of thread handling, allowing us to run the programs that run parallel without having to work on this thread manually, right? So if you are using parallel programming, right, then what this parallel dot for, this is nothing but a TPL, you can say task parallel library, right? Task parallel library in the sense multiple tasks are going to be executed parallelly, right? This task parallel library hides or abstract the low level details in the sense what, now how the thread is going to be created, right? How the thread is going to execute our application code, how the thread is going to be destroyed, right? All these things are completely hidden or abstracted to us. What we need to do focus is, we need to focus on the application code. What is our requirement? That is, we are only going to keep focus on the application logic. We do not need to care how the thread are going to be managed, right? In the case of a multi-threading, what we are doing, we are creating the thread, we are calling the thread, we are while creating the thread, we are going to pass the method name, then we are going to call the start method, we are having the join method, right? Many things, all these things we are doing manually. But in this case, we do not need to manage the thread manually. Everything is going to be handled by the task parallel library. We only need to keep focused on our application logic, and the rest will be managed by the task parallel library, or you can say TPL. What is a task parallel library, right? We cannot expect our sequential program to run faster on new processor. As we know, the processor technology advantages means to focus is on multi-core processor. Today's desktop having 4 cores, but the latest experimental multi-core chips up to 100, right? So nowadays, if you are installing, right, you can see on my machine, it's a 4-core processor, right? But nowadays, there is having 1000-core processor are also available in the market, right? So basically, and if you are using multi-core processor, then we should take the advantages of multi-core, right? If you are having 10 core, but you are only utilizing 1 core, then what is the meaning of having 10 core on my machine? There is no meaning. So basically we have to take the maximum, we have to utilize the CPU resources maximum, right? Not all, but I'm saying maximum, right? So in simple words, we can say that multi-core processor machines are now becoming standard, and the aim is to improve the performance by running a program on multiple processors in parallel, right? So by considering the above scenario, .NET Framework 4 introduced task parallel library that makes it easier for developers to write parallel program that target multiple machines, right? Automatically use multiple processor, which improves the performance, right? So in this case, once we implement the parallel programming, then automatically it is going to use multi-core processor of our machine. If a multi-core processor is not there, then if single core is there, then that core is only going to responsible to execute our application code. We are not going to get any error, but the application code is going to be executed sequentially. Clear, guys?
Yes, sir.
Right. So once you start discussing the program, practically you will get some better clarity. What is parallel programming? Parallel programming is a type of programming in which many calculation and execution of processes are carried out parallelly. Parallel programming means what? Many tasks are going to be executed parallelly. Many calculations are going to be executed parallelly. So in this case, I'm calling this method. Instead of a method calling, I can also write some calculation logic here. Those logic are going to be executed parallelly by using different threads, right? And the points to remember while working with parallelly, the task must be independent. What it means, now in this case, I'm executing this loop from 0 to 10. So it should not be any dependent, right? For the I value 0 till I value 9, this thing is going to be executed. And every time you run the code, that should be independent. There should not be link in between the previous call and the next call. They should be independent task, right? If they are dependent, then you cannot use parallel programming. Second, the order of execution does not matter. As we already discussed, if you are using multi-threading, then the order does not matter. It might be possible that sometimes, right, you will get in a sequential order, right? If you are executing your application using standard for loop, you will get the output in a sequential order. Why? Because the execution is happening sequentially. But in the case of a parallel programming, as multiple threads randomly take the input data and process, so you cannot simply predict the output of the application, right? So order does not matter. So these two things you need to remember. C# support two types of parallelism. One is data parallelism and another is task parallelism, right? Data parallelism means what? In this case, you can see this is a for each loop, right? And in this case, I'm processing some data parallelly, right? So this is nothing but data parallelism. And another thing is that task parallelism. Task parallelism means what? If you are having multiple tasks, right? Let's assume this is task 1, this is task 2, and this is task 3, right? Then what you can do, you can also parallel these things. Now what is my requirement? My requirement is to execute these 3 methods parallelly. These 3 methods are independent methods. Their input output does not depend on each other, so I can execute this 3 method parallelly. How? So by using these things, right? So what you need to do, so you just need to pass the method name as a parameter to these things, right? Method 1, method 2, and then method 3. So that's it. So now what happened? Okay, let me remove these things. I'll show you how to return data, how to pass data. So in this case, what is happening, right? So this is nothing but your data parallelism, right? Where using for each loop, right? You can process multiple data, and this is nothing but your task parallelism, right? By using parallel.invoke method, you can execute multiple methods parallel. And when all these methods complete their execution, then only the execution of this method parallel invoke is going to be completed. So basically, we are having two types of parallelism. One is data parallelism, and you can achieve data parallelism by using parallel.for and parallel.for each loop. And another one is task parallelism, and you can achieve task parallelism by using parallel.info, right? And the note point what? Now, just because we have the concept of parallelism does not mean we should use parallelism. We will see later that there are times when it is better to not use parallelism, because in certain cases using parallelism is slower than not using it. So the parallelism, parallel programming concept is available to us. That doesn't mean we should blindly use them, right? We need to do some performance testing, right? If I'm using parallel programming, what is the cost? If I'm not using parallel programming, if I'm using sequential programming, then what is the cost, right? And after doing the analysis, then only you need to decide whether you need to use parallel programming or not, right? I will show you some example, and I will show you that parallel programming is giving you less performance, right? Giving you poor performance than the sequential programming, right? That is also we are going to discuss. So basically, you can say if you are using task parallel library, right? And if you want to implement parallel programming, then you are having three methods. One is for, another is for each loop, another is that invoke method, right? If you go to the parallel class, then you will also see that there is a method called for, there is a method called for each loop, and there is a method called invoke, right? So basically, we are going to discuss these three methods in today's session. Any question from anyone?
No.
Right. So theory we have discussed enough. Now it's time to discuss some practical, right? So let me show you the output. So in this example, right, whatever I'm copy pasting, so this is a sequential loop. So as it is a sequential loop, so we can predict the output. What we are getting in the output, we can simply predict. We are getting the output 0 to 10, and we can predict. And in this case, the output is a sequential order, because this loop is a sequential for loop or standard for loop. So each element is going to be processed by a single thread, and hence we are getting the output in a sequential order, right? So this is the standard for loop what we have discussed, right? Now what I'm trying to do, I'm going to use the parallel for loop, right? Right, parallel for loop. Let me show you how to create. This is the standard for loop, right? Now for using parallel for loop, we have to use the namespace using system dot threading dot task, right? This is the namespace you have to use. Then you have to use parallel class, and if you go to the parallel class, then you will see there are three methods. One is for, another one is for each, another one is info, right? So this is the standard for loop. I want to convert this standard for loop to parallel for loop. How? Right? So parallel dot for. So while you are working with parallel for loop, so first point is from inclusive, right? From where you need to start. In this case, this for loop is going to start. This is nothing but your initialization variable, right? Initialization variable means I is started from 1, right? So from where you want to start. From inclusive means from where you want to start the variable, right? So I want to start from 1. 1 means this will include, right? So then two exclusive, and what is the condition? From this is the starting point, and what is your ending point? Ending point I'm providing 10, right? I'm providing 10, but if you look at this is from inclusive, and this is to exclusive. Exclusive means what? This is not going to be included, right? So in this case, if I'm writing, if I want to print the number from 1 to 10, right, then I can use this condition. Another condition what I can use this condition also. Yes or no? Guys, if I want to
Yes.
print the number 1 to 10, I can use this one. In this case, if I'm using less than equals to, then it is going to be inclusive, right? What it means? Now it will print a number including this one. And if I remove this, then if I put 11, then that 11 is not going to be included. Yes or no?
Yes.
So in this case, this is the inclusive, from this position, from this number, the loop will start. And this is to exclusive. Exclusive means what? It is not going to be included. I want to print the number from 1 to 10. Then what should be the number here? 10 or 11?
11.
11. And in this case, this is the counter variable. And using this counter variable, you can access the number from 1 to 11, right? 1 to 10. So again, here I'm going to use the same counter variable. But if you look at the third parameter, it is going to be an action delegate. Action delegate means you need to provide this using one delegate, right? So in this case, action delegate, and this I is nothing but your counter variable. And this I is going to store the number from 1 to 10. And once it stores the number from 1 to 10, right? Then you can access the values. Right? This is nothing but your parallel version of the for loop. So this is your sequential for loop, and this is your parallel for loop. Is that clear, guys? How to create parallel for loop? First parameter is nothing but from where you want to start. I mean what? For parallel, for well, you are creating a for loop. So three things is required now. One is counter variable, right? And another one is what? Your condition and your increment and decrement. And in this case, this increment and decrement is not required, because in this case, this is the starting, this is the ending, and here, this is nothing but your variable, or you can say lambda expression you need to specify. And using the lambda expression, you can access the element by using this counter, using this variable. Now, I is the variable which is going to hold the value 1 till 10, and you can access the I within this open and close curly braces, right? Now in this case, how many threads are going to execute, that I cannot simply predict. Depending upon the processing time, right, the number of threads is going to execute the application code. Later, I will show you how to manage the thread. Now, if you run the application, but one thing I can give you guarantee that the output might not be in a sequential order, right? If you look at the output, 1, 2, 3, 4, 5, 6, 7, 8, right? Then 10 and 9. Why 1, 2, 3, 4, 5, 6, 7, 8 in a sequential order? Is because if you go to our application, right? Then if you go to this, how many logical processors are there on my machine? 8. That means at maximum 8 thread is going to execute my application code. So you can see the output, first 8 are in sequential, then 10, then 9, right? Once they have completed, then again a new batch will be there, and that batch only 2 elements are there, so they are going to be processed simultaneously, right? Later I will show you how to manage the number of threads that you can allow the application code to be executed. But it's that clear what is parallel for loop?
Yes.
Right? So this is how you can use parallel for loop. What is the now see, you have understand what is the for loop and what is parallel for loop. Then sometimes in the interview they might be asked what is the difference between them. Can anybody tell me what is the difference between them? You will only tell me the difference, right? So you just tell me, in this case, how many threads are going to execute the code?
Single thread.
In this case, how many threads are going to execute the code?
Whatever the codes available on particular machine, like it may vary.
Exactly. In this case, can you predict the output?
Yes.
In this case, can you predict the output?
No.
So this is the difference between parallel for loop and a sequential for loop. That is what I have mentioned here. Clear?
Yes.
And you need to use only when the tasks are independent. It means the subsequent iteration do not need to state object made by the previous operation. See, in this case, each execution should be independent. See, I value 1. So I value 1 should be independent, right? That I value 1 should not be used by the next iteration, right? So that means whenever the iteration is independent, whenever the task is independent, then only you need to go with it. What? this is parallel for loop, right? This is the sequence, this is the syntax, and you can see this is the sequential for loop, and this is the parallel for loop, right? I have shown you this example. Let me show you once more, right? Now, right? So this is my parallel, this is my sequential for loop. What I have done, I have created one number 10. My counter variable is 0. 0 to 10 means it is going to print the value from, okay, let me put it as 11. It is going to print the value from 0 to, so let me 1 to 10, right? It is going to print the value from 1 to 10, right? And here I'm also doing the same thing. I'm printing the value from 1 to 10. And additional what I'm doing, I'm saying which thread is going to execute my application code. We know thread.current thread is going to return the current executing thread, right? If you go to the definition of this property, we have already shown gets the currently running thread. That means which thread is currently executing this code, that thread instance it is going to return, and I'm just going to print the ID of that thread, right? Then what I'm trying, I'm making this thread to sleep for some few milliseconds, right? You can say 10 milliseconds. And in this case, I'm using parallel for loop. This is the same. This is just the opposite, or you can say the parallel version of this sequential for loop. And in the logic, I'm doing the same thing. And here, for loop will start from the 1, and it will go till the value becomes 10. And why I'm 10? Why I'm saying 10? Because it is exclusive, right? If you go to the parameter, right, then you will see that second one is a two exclusive, right? Two exclusive means it will not include that one, but in this case from inclusive. Inclusive means including, exclusive means excluding, right? Excluding means it will not count that number, right? So it will go till 10, and you can access the values from 1 to 10 by using this count parameter, right? And then whatever you want you can do with this count parameter, right? And in this case I'm just printing the thread ID. Now let me run the application. You will see that this for loop, right, going to be executed by a single thread. You can see the ID of this for loop is going to be 1. And in this case, you cannot predict, right, how many threads are going to execute the application code, right? So you can see some thread is ID 1, some thread ID is 3, 5, right? 1, 3, 9, 6, 8, 5, 10, right? So basically what it means multiple threads are executing this parallel for loop. Clear? And
Yes.
you can see the output 1, 2, 3, 4, 5, 8, 7, 9, 6, 10, right? The output is also not in a sequential manner. So the two things what we have discussed, multiple thread is going to execute the code, and the output you cannot simply predict. This is the difference between your C# standard for loop and parallel for loop. Is that clear?
No, can I loop within the data set?
Sorry? See,
Within
I'm saying here, whatever you want, you can do. But that should be independent task.
Okay.
Right? So anything, see, if you want, you can call a method. Whatever operation you want, you can perform on that method. You can see, this is a block. Block means what? Any code you want, you can write. Any database operation you want, you can write. You want to update some data in the database, you can write. That there is no issue, right? But the thing is that should be independent task. Independent task in the sense, if I'm executing the loop for 10 times, right? So there should not be any link with the, suppose in this case, counter variable increase, right? That increased value is independent. It should not be used in the next iteration, right? That is the point that you need to understand. Independent task in the sense, there should not be any link between the next call and the previous call. It should be independent, right? And so you can use the data set, anything you can use. Clear? Right? So now I will show you one more example for better performance, right? For better understanding from performance point of view, right? So for performance point of view, in the sense, right? So in previous example, we have write some logic, right? Now you can see I'm using, this is a standard for loop, and from this for loop I'm calling this independent method, right? So do independent task method, right? In this task, whatever operation you can do, right? Most probably some calculation or DB related activities, right? You want to process some data in the database, right? You want to update some data in the database. That is also fine. That you can also do here, right? And in this case, what is I'm doing here? I'm doing a time consuming task. So I'm basically using this loop to generate a big number, and finally I'm returning that number, right? This is my time consuming task, right? So what I want to do, I want to call this method from my for loop, right? And I want to call this method for 10 times. So you can see I'm using this for loop for 10 times, right? And so if you want, you can write this is 10, this is all 11, that is also fine, right? So then I'm calling this. So what I'm trying to do is I'm just using the, what is this date time? This is not used, right? So what I'm trying to do is I'm just using the stopwatch to see what is the time duration the standard for loop to complete this task, right? To complete this task means to execute this for loop 10 times, right? How much time the standard for loop, or how much time it took to complete the task, right? That is what I'm printing here, right? Let me run the application and show you the output. So the tasks are going on, and you can see what is the time? 2889, right? So what is the time duration it takes? 2889 ms. Ms means millisecond, right? So this is the example using standard for loop, right? Any question from this example? Because this is a simple example, so I'm not explaining this code in detail, right? Because you know what is the code is all about. Any question from anyone related to the code?
No.
Right, this is a simple code, right? So simple for each loop, and in this for loop, so I'm just calling this independent task, and this independent task, by using a loop, it is generating a bigger number, and that it is returning that number, and I'm just printing that number along with the counter value, right? And then I'm just using this stopwatch start and stop, and I'm just fetching how much time it took to complete this execution, right? And in this case, you can see it is taking 2889 milliseconds. Now, what is my requirement? Now, what is I'm going to do? And one more thing, guys, you need to observe, right? So let me show you, right? So performance, right? Right. So why it is showing utilization is high? Because most of the time you can see the processor time is taking, Zoom is taking more time, Google Chrome is taking more time. Let me complete the Google Chrome, right? Let me complete these things because these are taking more time. Right? So CPU utilization, and Zoom is taking most of the time, right? So this is the reason why performance is going to be higher, right? But mostly, see, while you are running, right, then you will see that, see, whenever I do this test cases, right, in my cases, when I'm using the for loop, right, the CPU utilization is 42%, right? 42%, but I cannot show you right now. Why? Because I cannot stop this Zoom meeting, right? And you can see Zoom is taking most of the time, 31%, right? So I cannot show you this thing, but you can try this by your end, and you will see that CPU utilization is something related to 40 to 50%, right? Now what I'm going to do is I'm going to write the code using the parallel for each loop first. Right? So this is the same thing, but in this case, what I'm using this date time, but now it is not required, right? So in this case, what is happening? This is the parallel dot for each loop. So let me start with 1, let me end with 11, right? And everything is same. The same do independent task method with the same logic, right? Here I'm also doing the same calculation. I'm just calling this method, whatever written, I'm just printing, and I'm just showing how much time this parallel version of the for loop is going to take. So what is the time? 967, right? So what is the time? 967. So which is giving you better performance?
Parallel for loop.
parallel for loop. So why it is giving you better performance? Because you are doing a independent do independent task. This method, this task is going to take some time. Now what I'm trying to do, I'm commenting these things, right? I'm returning simply a value 10, right? I'm returning a value 10, right? Now let me run this application and show you this thing. So what is the milliseconds?
63.
63. With parallel, it is taking 63 milliseconds, right? Now what I'm trying to do is I'm going to use for loop. Let me comment these things, right? Let me use for loop. I equals to, let's start with the 1, length is going to be 11, and in the body, let me paste this thing, right? Now this is the for loop. Now let me run this application. What is the milliseconds?
1.
1. So what is the millisecond? So 1 millisecond. So so you need to understand. So parallel programming concept is available. That does not mean I can blindly use parallel program. Why it is giving, in this case, this is giving better performance. Why it is not giving better performance? That I will show you, that I will discuss in detail by taking some analogy after some time, right? But the thing that you need to remember is the task what you are going to perform, right? If it is not a time consuming task, right, then don't use parallel programming. So in this case, it is not a time consuming task. So if it is not a time consuming task, and if you are using parallel programming, then you will get negative performance, right? That is what I'm showing, right? But if the task is a time consuming task, right, then you need to go with parallel programming. Clear? Guys?
Yes.
And in this case, while using parallel programming, you will see that the CPU utilization is going to be high, right? But now one more thing that you need to remember, right? So in processor, right, you can see the number of available core is 8, right? The number of available core is 8. And if we are not limiting, right, if we are not providing any limitation, then whatever the number of cores available or are going to be used by the application, right? Now I don't want that. I don't want to use all cores to execute my application code. I want to provide a limitation. Limitation in the sense, I want only 3 threads to execute my application code. I want only 5 threads to execute my application code. I want only 2 threads to execute my application code. Is that possible? Yes, that is also possible. And for that, what they have provided one class called parallel options, right? This parallel option class is one of the most useful class when working with multi-threading. This class provide options, right, while working with parallel programming, right? So this class provide options to limit the number of concurrently executing loop thread, right? Concurrently, how many threads are going to execute the loop that you can manage by using this parallel option, right? How? Now this parallel option class having one property called degree of parallelism, right? Max degree of parallelism. And using this property, you can set the number of threads to execute the application code. And you can see I'm creating an instance of a parallel options class, and parallel option is like this parallel class, right? You can see this parallel is a static class, right? Parallel is a static class. So you can call the method directly, but in this case, parallel option, right? It is not a static class, right? Parallel option, you can see if you go to the definition, then it is not a static class, right? It's a class. And this class having one property called max degree of parallelism, right? And another property called task scheduler, and another property called cancellation. What is cancellation? We will discuss in detail, right? And you have some idea what is cancellation token, right? Can anybody tell me why I'm going, what is the use of this cancellation token? I have not discussed this token in parallel programming, but you should have some idea when and how that is different things when we are going to use this cancellation token. Can anybody tell me?
If all cores are taking more than some amount of time to release the core.
Exactly. So not to release the core. So basically, if you want to cancel the execution, simply speaking, if you want to execute a parallel execution, if you want to cancel the parallel execution, then you need to use cancellation. What is this task scheduler? Right. Suppose I'm using maximum degree of a parallelism. So if I'm allowing 3 threads to execute my application code, then it is the responsibility of a task scheduler, right? Task scheduler will decide, will schedule how the threads are going to execute the application code, and that basically depend on this maximum degree of parallelism. Right. So basically what you need to do is you need to create an instance of a parallel option class, and you need to set this property value, whatever number of threads you want your application to consume, that you need to set here. And then you need to pass this instance, right, parallel option instance, as a parameter to this parallel.for method. Now what will happen? Now the task scheduler will check this parallel option instance, and it came to know that yes, maximum 2 threads you want, right? Let me create only 2 threads and let me allow only 2 threads to execute the application code, right? So if you want to manage the number of threads to execute while you are working with a parallel programming, then you have to use this parallel option class. You have to use this maximum degree of parallelism property, and using this property you can set the maximum number of threads, right, that can that you want allowed to execute your application code, right? Let me run these things, right? So you can see I'm creating an instance of a parallel option class. This class having one property called this one, right, maximum degree of a parallelism, right? And this parallelism I'm setting with 2 means what? Now can anybody tell me how many threads are going to execute my application code? Maximum how many threads?
Two threads.
2 threads, exactly. 2 threads is going to execute my application code, right? Let me put this as 1. Let me put this as 11. So for the I value 1 to 10, it is going to execute, and then you will see which thread is executing my application code. That is what it is going to print, right? So let me run this thing. So you will see maximum 2 threads is going to execute my application code. Right. To give you a better idea also, what I can do is I'm putting this thread to sleep for 2 seconds, right? See, 2 thread executed, 2, 2, 2. So maximum how many threads now executing your application code?
2 threads.
2 threads. Why 2 threads executing my application code?
So here on the output, like there are like a different thread ID. So like for an example, on the first line, the ID of the thread is 1, right? So it is executing, then it is destroying and creating again, or the same thread is
Exactly. Once it is completely, it is destroyed and created again. This is the reason why I'm saying threading means what? Parallel programming means it simply to implement, to use parallel programming, something is behind the scene that is hidden to us, that is abstract to us, and that thing also has a cost. I will show you one analogy for this so that you will get better idea, right? But behind the scene, everything is the thread is created, the thread is used, the thread is deleted. Again, the thread is going to be created, used, and deleted. And in this case, don't think that thread pool thread are coming into the picture, right? So, but see, in this case, 1, 3. If same thread, then again it should be 1 and 3 now. But you can say again it is going to be thread 4, right? So,
yes,
that means what?
So on line number,
sorry
to interrupt you. So on line number 1, thread ID is 1, and on line number 3, the thread ID is 1. So the first line and the third line thread both have the same ID. So both are same thread, or
not same thread, right?
No,
But once they have created, once they complete their task, they are going to be deleted. Once deleted, again they are going to be created.
Okay.
Right. So you can say, and maximum of 2 threads at any given point of time is going to execute your application code. Right now, if I'm setting this value to 3, then you will see that maximum 3 thread is going to execute your application code. See, 3, 1, 3, 4. 157, right? 571, 1, right? So maximum 3 threads is going to execute your application code. Clear?
Yes.
Right? But guys, what is the best idea to use the threading means, number of means? So there is a class called environment. Inside this environment class, there is a property called processor count, and you need to set this value to -1. So number of processor that is available in your machine, right? So in my machine, what is the number of processors available? 8. 8. So 8. I don't want to use all to execute my application code as a standard, right? Generally in real-time application, right? What we are using this one. So number of a processor -1. Let me keep one processor to do something else, and let me use the maximum utilize of CPU, but not all. All and the maximum both are two different things, right? If I'm using this one, then this is all, right? And if I'm using this one, then that is maximum, right? And in this case, you will see that this property is going to give me it is going to give me 7, right? So, and you have to use this one because you do not know. So I have developed this application, and if I am hard coding the degree of parallelism, then I do not know on the system where this application is going to be run, how many processor in that system. It might be one processor, right? It might be 2, it might be 3, right? Minimum 4 nowadays, right? Apart from that, you can see there are 100 processors. Simply hard coding is not a good idea, so you have to use this one, right? Now, if you run this application, then you will see that the processor count property is going to be 7. What is the maximum degree of parallelism?
So
7, right? Task scheduler means it is going to be 8. Wait, I don't know what is the task scheduler because that is the part of operating system, and we do not need to think much about the task scheduling, right? Now, let me run this application code. Maximum 7 threads are executed, and then 3 threads is going to start executing, right? So this is how you need to use maximum degree of parallelism, right? So if you want to limit the number of threads that can execute your application code, you can hard code it the value, but it is always suggested to use this thing, right? Let me copy this code. Let me put it here. Right, so that you also have a reference to this. Clear, guys?
yes.
Right. So this is parallel for loop. Now I'm going to use parallel for each loop. So can anybody tell me when we need to use for each loop? Forget about parallel for each. When we need to use for each loop. So basically, if you have a collection, right, and if
Yeah.
that collection implement IEnumerable interface, then to iterate over the element of that collection, you generally use for each loop. Yes or no?
Yes.
Right. So similarly, if you want to create a parallel version of the for loop, then you have to use parallel for each loop, right? So this parallel for each loop, it is similar to what your for each loop. The difference is that in this case, like the parallel for version, in this case, multiple thread is going to execute the application, right? So, yeah, anyone asking any question? Okay, fine. Right, so you can say this example showing you this example is nothing but your sequential for each loop, and you can see what I'm doing here. I'm creating a list of integer, and in this case I'm using enumerable.range method. And what is this enumerable.range method is going to do? It is going to create a range of integer starting from 1, and the number of integer is going to be 10. From 1 it will create 10 integers, right, number, and that integer is going to be stored inside this integer list, right? And once we create, and I want to convert that to a list, to a dictionary, to an array, and you know, if you want to convert something to list, then what method you need to call? To list. If you want to convert this to an array, then what you need to do? you have to call to array. If you want to convert to one dictionary, then you have to call to dictionary. So in this case, I want to convert this to a list. So I'm calling this to list method, and I'm storing that in a collection of list of integer, right? Once you have the integer list collection, then you can use a for each loop to iterate over all the elements. But in this case, right, in this case, the execution is going to be sequential, right? The number of elements stored inside this collection, it will be fetched one by one, and that will be, this for each loop will fetch the elements one by one and store inside this variable I, and then you can do whatever you want with that value. In this case, the output is going to be sequential. In this case, only one thread is going to execute the this application code. Now, the same thing I want to do using a for each loop. So what is the process? The process is very simple, very similar. You have to use parallel.for each loop. And in this case, here you are passing, you need to pass the collection. I'm passing the collection. I'm using this I such that this is the lambda expression. And within open and close curly braces, you can write whatever you want. So in this case, what will happen? Now the multiple thread will going to execute this application code. Right, whatever the number of elements that are available inside this collection, that will be stored one by one inside this I, but not one by one. Multiple thread means multiple thread is going to execute this piece of information, right? So this is the parallel for each version of this for each loop, right? So in this case, multiple thread will come into the picture and will execute the application code. Clear?
Yes.
Right. Now let us see some of the examples so that you will get a better clarity, right? So, right. So in this case, you can see I'm using stopwatch. You know what is the use of a stopwatch. I'm starting the stopwatch, I'm stopping the stopwatch, and I'm printing how many times this standard for loop to complete the execution, right? So in the, and then what I'm doing, I'm creating a list of integer, right? So if you go to the range method, right, then you will see that this method taking two parameters, start and count. So what is the use of start parameter? The value of the first integer in the sequence. What is the count? The number of a sequential integer to generate, right? The number of a sequential integer. Sequential integer means what? If the start value is 1, then it will generate the integers like 1, 2, 3, 4, 5, 6, 7, like this. How many number of integer you want to generate from this one? That will be specified by the count method, right? So in this case, can anybody tell me this list of int collection going to store how many numbers and what are the numbers?
1
Guys?
to 10.
1 to 10, absolutely right. Because why? Because 1 is the starting number. How many sequential number? 10 sequential number. So it is going to 1, 2, 3, 4 up to 10. And then I'm using a for each loop. You know how to use for each loop to iterate through a collection. And in this case, each element that is present inside this collection will be accessed by using this I variable. And in this case, once you access, then you can call this do independent task time consuming method, right? And then you can simply print this thing, right? And in this case, only one thread is going to execute the application code. And this is my do time consuming method, right? No need to explain this method because we have already discussed this method. So in this case, it is going to generate a big integer number, and that integer number is going to return. And while generating the big integer number, it is actually going to take some time, right? This is the reason why I'm saying this is the time consuming task. And then I'm simply printing the value, right? So now run the application and see what is the time duration. Right? So it is taking 2708. 2708 milliseconds, right? Now what I'm trying to do is I'm going to use the parallel for each loop version. Right, the same thing, instead of for each loop, I'm using parallel.for each loop, and I'm providing the collection, right? If you go to the definition, you will see that this is the source. Source means the collection, and this is the action predicate, right? Action delegate means you have to specify this thing using the lambda expression. And to this lambda expression, my input parameter is this one, and I'm using that I inside this body, right? So now this is same as our previous for each loop, but in this case, multiple thread is going to execute the application code, right? Now let me run the application and show you the time taken by this for each loop. So what is the time? 971. So which one is taking more time? Standard for loop or parallel for loop?
Standard.
Standard for each loop taking this time and parallel for each loop taking this time. So you have to remember. Now again, if you are not performing a time consuming task, right, then again you will see that the standard for loop will give you better performance comparing to this one, right? That is what you need to remember, right? So you can see, and if you want to use degree of parallelism, then you can also use, right? So how? Let me show you this one example. Right now, if you want to limit, right, this is the parallel for each loop, right? So in this case, you can see this is my integer list collection, and in this case, you can see how many threads are going to execute the application code that I do not have any control. See, you can see 1, 2, 3 threads are executing my application code. Now, if you want to manage that maximum 2 threads can execute my application code, right, then you can also manage that by using what? Maximum degree of parallelism, right? What is the class name? Parallel options, right? And once you create the parallel option class, right, then there is a property called, what is the property name? And if you want to set this to 2, right, then you need to pass this as a parameter here before the delegate, and now run the application, and then you will see that maximum 2 threads is going to execute your application code, right? So maximum 2 threads executing your application code at the same time. Here, if you want to see the output, what I can do here, thread.slave, I'm putting this 2000 here so that you can see the output. At maximum 2 threads at any given point of time is going to execute your application code, right? So this is the use of a degree of a parallelism, right? How to control the degree of concurrency, how to restrict the number of threads, that is what we have discussed by using the parallel option class, right? Speed benefits of parallelism, right? Speed benefit of parallelism means what, right? So we have already understood that increasing the speed is the most important reason for using parallel. Why we are using parallelism? Simply to improve the application performance. How we are going to improve the application performance? By utilizing the CPU resources effectively. How we are effectively utilizing? Because we are executing our application code using multiple threads, and all these things are managed by the TPL, task parallel library, or you can say parallel class provides a method. By using those methods, we can easily implement these things. Now the question is it worth using parallelism, right? Let us understand this with an example, right? Suppose you are a teacher. Right? And you are assigned one task that you need to correct the exam, right? For one exam correct, you took 4 seconds, right? You took 4 seconds, right? And now you can independently do this. If you want to correct one exam, right, which is conducted one student exam, if you want to correct that exam, right, then it is going to be taken by you 4 seconds. Now what is required? Now instead of you are doing this task, right, you think that let me hire, you can say, or let me search 2 persons, right, 2 assistant, right? You search for 2 assistant, right, 2 assistants to do the task. And for searching 2 assistant, what is the time you took is, for searching the assistant, you took 45 seconds. 45 seconds, right? See, alone, if you want to correct the exam, you took 4 seconds. Now you thought that, yeah, I'm not going to do this task, rather I'm going to assign this task to someone else. And for that, you have assigned 2 assistant, and for searching 2 assistant, it took 45 minutes, right? Now, if this exam, right, one exam to correct, right, if this task to be corrected not by you, but by your assistant, then what is the total time duration? So the 45 minutes, what is there for searching the assistant plus the 4 minutes. So what is the total time minutes? Yes or no?
Yes.
Right. So basically, if you alone do this thing, then you can do this by 4 seconds. Now you thought that, yeah, I'm not going to do this. Let me search to assistant and let me assign this task to one of the assistant. Then for searching to assistant, right, you are taking 45 seconds. Then once you assign this task to someone else, that person is also going to take 4 seconds. Then what is the total time duration? 49 seconds for correcting one exam, which you can alone solve in 4 seconds, and by assistant, what is the time duration? 49 seconds. That means which one is giving better performance, you or by searching to assistant? Which one? First one. Now, so in this case, this is nothing but your single thread, and this is nothing but your parallel programming. So in this case, it is clearly saying that single thread giving you better performance. Now, what is my requirement? I'm not going to correct one exam, right? I'm going to correct 150 exam. And if 150 exam, then what is the time duration if you do this as alone?
600 seconds.
160. Yes or no? Per exam, it is going to take 4 seconds. 150 exam means what is the total time duration?
600.
Yes, 600, not 160. It is going to be 600, right? Now, what you are going to do? Now you along with the two assistant wants to correct 150 exams. Then what is the time duration? Right? You and alone with the two assistant means 3 people or 3 threads going to execute this 150 task, right? That means independently, one thread is going to handle 50 tasks,
Yes.
right? That means what is the time duration? 45 minutes for searching, then 4 minutes into 50, right? 4 minutes into 50. So what is the total time duration in this case?
245 seconds.
245. So alone, what is the time duration?
600.
And using parallel programming, what is the time duration?
240.
245 seconds. So now you need to decide whether if you are having a small task to do, then instead of using parallel programming, you need to go for sequential programming. And if you have multiple tasks to do, right, heavy tasks, right, multiple number of tasks to do, right, then instead of you alone doing the thing, right, it is better to assign or better to use parallel program. This is the thing I have explained here. Right? So something similar happens with parallel programming. Sometimes the work to do is so small, so little that it is faster to use sequential programming and not parallel programming. The important thing is to take measurement before and after introducing parallelism to make sure that parallelism really pays off. Right? So what it means if you are using parallel programming, right? So please do practices. Practices means measurement. Measurement means try to do the same thing using sequential programming and try to do the same thing using parallel programming. Then you just identify which one giving you better performance, and accordingly you need to decide whether you need to go with parallel programming or whether you need to go with sequential programming. Is that clear?
Yes.
Right. Now I'm going to give you a better I'm going to give you an example, right? Let me show this. So here this is my standard for loop. I'm using stop and stopwatch to show how much time this is going to take. And this is my parallel program. I'm also using start and stopwatch. And this is my sequential program, right? So in this case, this execution, it is not you can say it is not a heavy task. This is a small task, right? So small task means let me run this application code. See, sequential programming took 1 milliseconds and parallel programming took 65 milliseconds, right? So you should take into consideration whether I need to go with parallel programming or whether I need to go with sequential programming. Clear or doubt?
Yeah.
Right? So the last thing that what today we are going to discuss is, see these two things what we have discussed, this is nothing but your data parallelism, right? So I have shown you two types of parallelism. This is data parallelism, right? Data parallelism means we are processing the data, right? In this case, we are processing the data, right? The next one, what is with us is task parallelism. So task parallelism, let's say how to implement this task parallelism, right? Right. So now we are going to discuss the parallel invoke method, right? The parallel invoke method is actually one of the most frequently used static method of the parallel class. So far, we have used parallel for and parallel for each loop to run same block of code multiple times in parallel. However, sometimes we want to invoke different independent methods in parallel which are not part of a code block, right? So in this case, if you do not have a for loop, if you do not have a for each loop, right? And if you are having some independent method, right? Then if you want to execute those independent method parallelly, then you need to go with a parallel.invoke method. For example, now I do not have any loop, right? So now some three methods are created, right? Right. So you can see this is method one, you can see this is method two, and you can see this is method three, right? Some independent method. This method doesn't have any relation with this one. This method does not have any relation with this one, right? Some independent methods are there, right? Now what I want to do is I want to execute this method independently. Then if you want to execute this method independently and sequentially, you can directly call this method, method 1, method 2, method 3. And in this case, this method execution will start. Once this method execution completed, this method execution is going to be there. Once this one completed, this method execution is going to happen. Until and unless method 1 not complete its execution, method 2 is not going to start. Why? Because this is sequential, right? And in this case, let me run this application and show you how much time this method execution took place, right? Sequentially, if I'm executing these three methods, then what is the time duration? It is taking 21 milliseconds, right? Now what is my requirement? Now what I'm going to do, instead of calling this method sequentially, what I'm going to do, I want to call this method parallel. Parallel means by using three different threads, I want to invoke this methods parallel. So parallel class, one method is called invoke, and this method invoke, you need to pass the method name. That is what you want to execute. What are the method you want to execute? You want to execute method 1, you want to execute method 2, right? And you want to execute method 3, right? So in this case, simply you need to pass the three methods. And once these three methods you pass, this method parallel that invoke execution is only going to be completed when all these three methods complete its execution, right? Now run the application and show you the output. So you can see it is taking 32 milliseconds. Previously it took 21 milliseconds. Now it is taking 32 milliseconds. Why it is taking more time? Because internally to execute these three methods, right? Three threads are going to be created behind the scene, right? If three threads are created behind the scene, to manage those threads, right, it is taking some time, right? Now what I'm going to do, I'm increasing this time. I'm increasing this time, right? 200, 200, 200, right? So 2002 seconds, right? Now run the application and show you the output. So what is the total sequential execution took place? Not it is sequential, it is 74 milliseconds, right? Why it is 74? Right? So some 149 milliseconds. Every time you run the application, you will get a different output, right? Now, what I'm trying to do, right? Now, again, I'm going to unblock these things, right? I'm going to unblock this thing, and now I'm going to execute these things, right? 21 milliseconds. Why this is not? So the thing that you need to remember, I don't understand why it is not task dot delay. Yeah, exactly. Task dot delay. It should be thread dot sleep, right? Thread dot sleep should not be task dot delay. That is what I'm saying. Why it is not affecting, right? So it should be thread dot sleep method, right? Now run this application and see the output. Right, so 6017 milliseconds, right? Now what I'm trying to do, I'm commenting these things, I'm uncommenting this one, right? Now I run this application. See, 2029. So basically you are getting better performance now, right? So the point that you need to remember, so using sequential programming, the methods are going to be executed one by one. And if you are using parallel programming, all these three methods going to be executed parallelly, which will give you better performance. Is that clear?
Yes.
Right. So many things we will discuss. In this case, the method does not take any parameter. The method does not return anything. If method taking parameter, then how we can pass that value? If method returning something, then how we can store that value, right? Everything we are going to discuss, right? But after some time, right? This is what we have discussed, right? So example to invoke different types of a method, right? Okay. So guys, if you look at this parallel.invoke method, right? So it is taking some action parameter. So what is action? Action means it's a delegate. Delegate means what? You can pass a method, even though it is also possible to pass what? Anonymous method. It is also possible to pass what? Lambda expression. Let me show you these things practically. So in this case, this is my normal method, right? So using this invoke method, I can pass a normal method, right? Like this. This normal method is going to be executed. And I can also execute one task by using anonymous method. This is nothing but your anonymous method. You know how to create the anonymous method, right? And what is this? This is nothing but your delegate, right? So using this parallel invoke method, not only you can invoke the normal action method like this, normal method like this, but also you can execute anonymous method, and you can also execute lambda expression. And all these things are possible because this invoke method, right? This invoke method is expecting one action delegate, and as it's a delegate, so you can pass one method, right? Or you can pass some anonymous method, or you can pass some lambda expressions, right? So in this case, if you run this, will execute this block of code, and this delegate will execute this one, and lambda expression will execute this one. Let me run this application. See, so all these three things are executed by three different threads. Clear? Right?
Sir, one doubt is like till now what we use like parallel dot for each. Are they going to responsible to execute only loops,
Yes,
not
yes.
the
Yes,
methods?
yes. That is, see, for and for each loop. For and for each. If you compare this with the traditional, what is for? For is a loop. What is for each? For each also a loop. Yes or no?
Yeah.
So for loop, for when the loop is there, then you can see if you are having a for loop, or if you are having a for each loop, right? Then you can convert those for loop and for each loop to parallel for loop or parallel for each loop, right? But if you are having multiple method, right, that you want to execute parallelly, then you need to use parallel input,
Okay.
right? Any question from this example? What is this and what is this?
No question for this example, but I have the same question as Bhargav asked. Like, so basically, like we are using this parallel features, like when we are like fetching data from loop or something, right?
Exactly. Suppose you are having a for loop, right? Or if you are having a for each loop, right? Suppose you are creating a for loop, and if you are in your application, you are going to use a for each loop. right? So in that case, right, if whatever code you have written inside the for loop or inside the for each loop, if that is independent, and if that particular task, right, in this case, the loop is going to execute for 10 times. Each time the loop execute, it is going to perform a task. If that task is an independent task, if that task is going to take some time, then instead of using for loop, you need to use parallel for loop. Similar in the case of a for each loop. Clear?
Yeah, that I understood. But like, is there any use cases other than like a for each loop and invoking method?
There is no other use cases. For each loop, parallel for and parallel for each loop means only they are going to be used in the case of a looping,
Looping, okay.
right? And other than this, if you do not, if you are having some different methods, right? Then if you want to execute them parallelly instead of sequentially, then you can use this parallel in. And in this using parallel invoke, you can specify the method like in the previous example, I have shown you 3 methods. Instead of method, you can specify some delegate. You can also specify some lambda expression, right? But coming to that question, for each loop and parallel for each loop means they are only going to be used in the case of a looping. Other use cases is not there, right? So why see in this case, why I'm going to use that in the case of loop? Because I know the loop body is going to be executed for 5 times, 10 times, 100 times. If you are not using a loop, is there any chance that loop body is going to be executed for more number of times?
No.
Then what you say? See, if I'm having some straightforward code, right? This control.write line, right? Or some integer x equals to 10, right? Some integer y equals to 20. So these are not going to be executed multiple times. Means this is going to be executed one time. This is going to be executed one time. This is going to be executed one time. Does it make sense to execute this code line using a single thread? This line using a different thread? This line is a different? No, it's not required because they are going to be executed only once. If they are going to be executed multiple times, means they should be inside a looping. Looping is basically used when we want to execute some piece of information multiple times, right? Repeatedly, we want to execute. If we are executing repeatedly, then there is a chance that instead of executing the loop body one by one, we can execute the loop body by using multiple threads, which can improve the application performance, right? And for that case, you need to consider using parallel for loop or parallel for each loop, right?
Yes.
And another scenario is that you are having a few independent methods, right? And if you want, and each independent method is going to perform a time-consuming task, then in that case also you can use parallel.invoke method, right? So in that case, it is going to work, right? And same concept is also there, right? If you want to control the number of threads to execute your application code, then that also it is possible using what? So in this case, you can see parallel.invoke. I'm calling this do some work method, right? And this is the invoke do some work method. I'm passing some integer value, right? Whenever you want to pass some integer value, then you need to use delegates, right? So this is nothing but your delegate. Using delegate, I'm calling this method, and while I'm calling, I'm passing the input value, right? So in this case, 1, 2, 3, 4, 5, 6, and 7, right? That means this method is going to be executed 7 times by this invoke method, right? Now, if you run the application, then you will see that, right? All the methods are going to be executed at the same time, right? So all the methods are going to be executed at the same time, right? Now, what is my requirement? See, in this case, all the methods are executed by the same time. After 5 seconds, right? You can see thread.sleep. All are going to be completed, right? Now my requirement is that instead of executing all these methods at the same time using all the available threads, right? I want to limit maximum 2 threads or maximum 3 threads should execute my application code. Then in that case, again, you have to use that same parallel option class, right? And using that property, what is the property name? Maximum degree of parallelism, you can set the value, right? And then you need to pass this as the first parameter. That's it, right? So once you pass this parameter, then the thread scheduler will check this parallel option class, and it will come to know that yes, Now I'm going to execute this method, right? Whatever the number of methods by using maximum 3 threads, right? So now if you run the application code, right, then you will see that 3 threads are started. Once 3 threads are completed, another 3 threads are going to be started. And in this way, it is going to execute the application codes, right? So we have already discussed this thing, right? So this is how the application execution is going to be happening. Any question from this example?
Yeah, so on line number 19 to 25, we have used the lambda expression, right? So instead of using lambda expression, can't we write direct like a do some task one, do some task two, like a
No,
task one?
you can. See, if that method what you are executing, if that method signature is same as action delegate, right? If that method is not a non-returning method, and if the method does not take any parameter, then you can directly pass, right? Whenever the signature varies, right, then you have to use that lambda expression, right? For example, in this case, I'm using static void sum method, right? Sum method, and in this case I'm not taking any parameter and I'm not returning anything, right? Then this is a method which signature is same as action delegate. You can directly pass this one, right? You can pass this one, right? But now if this method taking some parameter integer x, right, then you cannot pass here. You can see immediately it is throwing me some error, and you cannot simply pass the value like this. This is not possible, right? You have to specify this by using the lambda expression, right? And you know how to use the lambda expression, right?
Yes.
And this is how you need to call the method with the input parameter, right? So is that clear, this example?
Yes.
Right now. So as of now, whatever method we have discussed, right, those method are some of the method returning some data, not returning method, right? Means what? The methods are not returning anything, right? Now I will show you one example where some method will take some input, right? This is the method which does not take anything, but it is returning some integer value. In this case, the method taking some string parameter and returning some string value. In this case, this method does not return anything, right? But it is taking some input parameter, right? And now I'm creating another method, right? Not required. Already we have seen this thing. And this method does not take any parameter and it is not returning anything, right? I'm having 4 different methods, right? So method with returning without input, method taking input and returning value, method taking input not returning, method not returning and not taking any data, right? Now if you want to invoke these 4 methods, then how you will invoke, right? So I can also invoke this method 4 like this, right? Even though if you want, then you can directly invoke this method 4 like this. This is also possible. Why? Because the method 4 signature is same as the action delegate, right? If you go to the action delegate, then you will see that this is a non-returning, I mean the return type is void and it is not taking any parameter, and whose signature is same. If it is same, then you can directly pass, right? Even though using delegate, you can also call that method, right? So both the approaches I have shown you, whichever approach you like, you can store, right? Now, if you look at this method 2 and method 1, they are returning some data. I want to store that data. How I can store? So what is the return type of this method? Integer. What is the return type of this method? String. So first of all, I need to create 2 variable and I need to initialize it with the default value. Integer, I initialized with 0, right? String, I initialized with empty. Then while calling the method, this method is going to return some integer value. So I have stored that return type using an integer value. This method is going to store some string value. I have to store that value inside a string variable. This method return anything? No. So no need to store the return type. This method returning anything? No, it is not returning. So I don't require to initialize a variable and where I need to store the return value, right? So in this case, you can say once this method execution completed, and this method execution is going to be completed when all the 4 methods are executed completely. and then this string result will store what this method one return, sorry, integer result, and this string result will store what this method two return, and then you can access those values, and whatever you want you can do. Right now, let me run the application and show you the things. Right. So four threads are started by four methods are started by four different threads. Method one result is 100. Method two result is hello product. Clear? Guys,
Yes.
right? I have not discussed one thing, how to cancel the execution, right, of a parallel operation, right? That is what I'm going to discuss separately, right? But for now, today, I'm going to cover the main thing. Main thing means parallel programming, how to implement using parallel for method, using parallel for each method, and using parallel dot invoke method. Anyone used these three methods in any of their project? Anybody?
Yes,
Abhi?
sir.
You
Yes,
have
sir. So,
you used, right?
sorry.
I mean, you have used this parallel operations on your project, right?
No, no, no. I have a question, sir.
Yeah. Ask.
Yes. So, like from a real world example, so we can say that is the parallel, the use of parallel is only for like performance issues.
Exactly. Parallel programming is basically to improve the application performance. And that application
Okay.
performance means only if it is CPU related operation. So there are two types of operation. One is CPU bounded operation, whatever example I'm discussing in this case, right? The operation is completely depend on my processor, right? On my machine, right? This code is going to be executed on my machine. So in that case, right, I'm going to use parallel programming, right? Instead of this, if I'm consuming some web API, right? I'm consuming some RESTful services which is developed and deployed by someone else. Then in that case, this is not going to be a CPU bound operation. Why? Because I cannot manage that manage the CPU of their external system, right? So that how they are developed the application that is going to be executed on their machine, depending upon the processor and all this thing, that application is going to be managed by them. I just need to call that operation, and that operation is external to my system. So as the operation is external to my system, you can say it's a IO bound operations. And whenever you are implementing IO bound operation, then you need to go with asynchronous programming. And whenever you are developing some application which is CPU bound, then in that case you need to use parallel programming. And again, if you are using parallel programming, then you need to do some research in the sense you need to do some performance measurement, whether actually the parallel version of the method, right, parallel implementation of the logic is actually improving the application performance or decreasing the application performance. If it is increasing, then only you need to use, otherwise the sequential option is already there. Clear?
Yes.
Sir, I have one doubt.
Yeah.
Like as you said, the parallel programming is only for CPU bound. Means if we are executing the application in our local or
Not local. It is. I'm not saying local. Wherever this application is hosted, there the application is going to be executed. Now, if you are hosting on your local machine, it is local. You can also host this application. You have developed one web application, right? That web application you have hosted on a server. So in that case, what is the CPU available on that server? Those CPU, the course is going to execute your application code.
okay.
Right, it is not related to local. On so in this case, I'm executing this machine on my local, so I'm showing you the processor and the CPU of my local, right? If you host this application on a server, then you need to check the server resources, what is the core available on that server, right? That based on that core, that CPU is going to execute your application code.
Okay, so whenever we want to increase the performance of our application, then we need to go for parallel programming.
Exactly. So simply, can you increase the other application performance? See, I have developed one service. I have given that service to you to consume the service, right? So I have developed the code in such a way that it is taking more time. Can you increase the performance of my application from your end?
No, sir, it is not possible.
So in that case, you can use which programming? Parallel or asynchronous programming?
Asynchronous programming.
Why asynchronous programming?
It will take
Because
its own time to return the
no,
output.
if you are using asynchronous programming at a time, once you make the async call, that thread is going to be released now. That thread which is calling that async operation, right? That thread which is calling my service, that thread will be released. That thread is going to do a different task.
Correct.
Right? That means why we are using asynchronous programming or parallel programming to effectively implies the threading concept only.
Okay.
Right?
So mainly like asynchronous programming is utilizing the thread pool threads. Here it will create the new threads for its use.
Right. Thread pool thread, here it is creating new thread. And second thing is that asynchronous programming is basically used when you need to communicate with the external system. And the parallel programming is basically used when you need to improve your application performance. If you are developing, that means it is going to utilize your CPU resources effectively.
Okay. Okay.
Right. Any question? Any other question from anyone? Guys?
No.
Okay. Okay. Okay, thank you guys. See you on Monday. Monday, we are going to complete this parallel programming. Few small concepts are there, right? One of the concept is that cancellation, right? How to cancel parallel operation, and few other things are remaining that we will try to complete on Monday. And from Tuesday, we are going to start ADO.NET. And before ADO.NET, I would suggest you all to install SQL Server on your machine. Right, SQL Server database and SSMS, right? SQL Server Management Studio the tools, right? You have to install, and please be ready with your database, because we are going to start interacting with the database from Tuesday onward, right? So this is mandatory thing, right? If you have not installed SQL Server and SSMS, then please be install it on your machine and be ready. Right, because we are going to start discussing ADO.NET. And after ADO.NET, we are going to start Entity Framework. And after Entity Framework, we will start discussing AutoMapper. Then we'll discuss that LenQ queries, right? And a few concept file handling, right? Reflection, which are missing, right? Those are also going to be covered.
So,
Okay.
so like ADO.NET and Entity Framework, like both we are using to fetch the data from database.
Exactly. Both are basically going to use the data, fetching the, I mean, basically not, you can say fetching the data, or rather it is good to say CRUD operation, right? Not only fetching, select, you can also do insert, update, delete, everything.
Okay, then why we are like using two different things like ADO.NET and the Entity Framework?
I'll explain you everything in detail, right? Not
okay,
now.
Okay.
See, if you are using ADO.NET, then everything you need to do manually, right? If you are using Entity Framework, then you do not need to write the code for performing the CRUD operation. You just need to tell the framework, hey, Mr. Framework, can you do this thing for me? I'm not going to write the insert, update, delete, all these queries, right? For me, can you write this and can you execute this thing on the database? And you just need to give instruction or information to the framework, and behind you, the framework is going to do all these things. But if you are using ADO.NET, you have to write everything manually.
Okay.
Right? Again, ADO.NET, there are three flavors, right? Code first, model first, database first approach, right? So as I discussed, model first is not used, right? So I'm not going to touch that. So I'm going to show you database first, right? Which is mostly 99% time used, and I'm going to use code first approach also.
Okay.
Right, so I'm going to explain you every concept using database first approach, and then I will show you how to use code first approach, right? And the same concept I'm not going to repeat again in code first approach. By taking one approach, I will explain everything, and I will tell you how to use other approaches by taking examples, right? And the concept is going to be same, so no need to explain this thing again and again, right?
Yep.
Okay. Yeah. Thank you guys.
Okay, see you. Bye-bye. Have a good day.
Thank you. Bye.